over there behind Scott is the stamp game, and that's all the operations with the stamps. And they can do carrying and borrowing using the stamps. It's a form of abstraction. And the snake game with the beads can be worked on the table, and all you're doing is finding out what makes 10. Well, here's 6 and 4 make 10. But we have 3 more here before we can take that away. So we have to take this out, put that back. We're going to change this whole thing into a golden snake. So now we can count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. To there. There's a 10, but what do we have here? 1 left. Okay, now we can start again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So they're just always getting what makes 10. And then you check yourself at the end against the 10 balls. In the other classroom, I've set up the upper elementary material. So if you want to see that, and that's volume and cubing and algebra, the beginning of algebra, and then how we go into abstraction. So if you want to get something to eat or take a break for a minute, or if you want to just go on over there, we can be out early.
My daughter who's 4 and never had an approach to this. How does she get steered to begin? If there's not a natural inclination to go in that.
Well, first we would check and see what she knew. She recognized her symbols, and she knew the quantity for the symbol. We asked her to go get 6 when she's playing the memory game. And we asked her to get 6, and she brought back 6 and 10. I mean, maybe asked for 15. I mean, we would try and see where she's at. If she didn't know her teens, if she's counting and didn't know her teens, we'd take her to the teens. Most children don't know place value. So we have a lot of work with all the children on place value. And that they love, because they can go and get it, and they're fetching big numbers, and they're putting them together, and they're writing them down. And if she's not writing yet, she's just playing the games, and that's fine too. So they're getting that cross-section right there, because she probably doesn't know her teens, or doesn't know what the quantity is. Maybe heard it, but doesn't know what it is. And so she needs to go on from there, and then they progress through.
If the child doesn't have a natural inclination to move towards the mathematic, manipulative, and this part of the learning, does the teaching staff direct a portion of their day in that direction?
Yeah.
Okay.
Yeah. You pretty much have to get it. And we count every single day, and we do the alphabet every single day. They know their sounds, and they hear the counting, the calendar, the date, the time is all done. I can't imagine they're not drawn to the beauty of this and just being able to manipulate it. Just counting is nothing, and just writing is nothing. Actually working with their hands on the materials. And you should put your hands on the materials tonight. If you can't, go over and see if you can work on something, or put, see how it feels, so that you can sense what the child is experiencing. And that's a big difference.
The beauty of Montessori too is with the older children who already know the jobs, the littler ones are looking forward to it. What's nice within the classroom is encourage each other.
And as a parent, not having these kinds of supplies at home, how does a parent support mathematic knowledge as it progresses?
Whenever the child brings up to you something like, oh, there's 3 birds. And you say, oh, and one just flew away. 3, and take away 1 is, how many left? 2. I mean, just realize that they're at a very basic level. And you're not going to force anything down them, because we don't either. We try to make it as interesting as possible. We try to involve them in it until that inner teacher takes over, and they go, I like this. I want to do some more of this. This is really feeling, good for me. And then you go forward. Some of them gallop through these. Amazing work that they do. And some of them, they kind of drift through, and they do a little bit. And that's all right, too. They all get there. It's just we don't want to create any holes. So we do want to move through, like progressively through it.
Yeah.
And whenever the teacher tells you they're working with the 10 boards, so you're thinking 10, 20, 30, 40, 50, you're going to try and count as many times as you can, or the 100 board, let's count to 100. Or they're on the decimal system, let's count 1 10, 2 10s, 3 10s, 4 10s. If they're working on the fractions, oh, family line, family name, something that's reinforcing what they've already done. I know that Rebecca and Barbara and some people talk to the parents about what they did for that day, so that they can have some sort of basis.
One last question is, where is the applicability of, say, the computer programs that are geared towards preschool math learning and I mean, they're obviously teaching symbols and they can't, there's no hands-on visual or tactile experience there. What is your recommendation about those?
I think people are selling short the mind of the child, I mean, they're saying, okay, they can learn from watching the video game before the age of 7. No, the child has to have their hands on the material before the age of 7. Otherwise, it's just, putting it together and sitting in the memory and not really a muscle to what the actual number is. Mm-hmm. And so it's going to leave them without a sense of what 1,000 is. Mm-hmm. It's just a number on the screen. Mm-hmm. No, the 1,000 is the cube of 10, and it's so much bigger than a unit. Mm-hmm. But you just give them a blank screen. It doesn't work. 7 years of age, they've got the foundation, they've hopefully had hands-on all the materials.
They've moved to the symbolic and the abstract,
exactly.
and then you can take them other places.
Right, exactly. Mm-hmm. Otherwise, you're missing all those bridges that need to be built. Mm-hmm. And Aristotle said, what goes through the head goes into the brain. Mm-hmm. And before the age of 7, they learn 80% faster than any other time in their life. Mm-hmm. And they build up that muscle in the brain at that time. And after that, it's harder. So if you want to see the AB squared, and then the B cubed, and that's the binomial theorem. And then they put the numbers with it, the 6s and the 3s, and they multiply it all out, and it equals the cube of 9. So they do it both algebraically and numerically.
And these are kids who are 12 years old?
These are these
Fourth graders.
Fourth graders, right.
Okay, which is
Right.
these
Okay.
next year, well,
Yeah,
her
Paxton,
next
next year. And the
Wow.
square root of the number, of course, is just the square, one side of the square. So they take out 81 beads and they start making a square, square, and then it's all done. Then they've got 9 on each side. So the square root of 81 is 9. Oops, sorry. Volume is done in plane figure and solids. We also do measurement with liquids, so they can see if volume is the same for the cone as it is for the cylinder, or the different volumes for the different pyramids. And from there, we've given them every basis that they need for abstraction. So now since they have fractions in lower elementary and primary, they can do the 4 fraction books. They can do measurement. They can do the percents, because it's the same as the decimal system. Geometry and algebra. Each of these says a certain number of books. This is 10 books in algebra that they do before the age of 12. But it's wonderful. It's absolutely wonderful. They've got all the foundation. In geometry, there's 8 books. Decimals, I think, is 4, right. 4 in percents, measurement, and fractions.
and basically your whole program from beginning preschool on up is to cover these areas. You had said
Right.
for group, but it's to cover
It's to cover all these
6
areas, right. Because
potentially.
percents and decimals and fractions are all the same thing.
Right.
We give it to them all at the same time.
Right.
They just had the solid exposure to it, fractions over there, decimals here,
Right.
and percents is the same. So by the time they're 12, they're supposed to have done all of this. And that's mathematics. And geometry, of course, they've had from just learning the point, the line, this plane figure, the square, and the cube. So they're starting to learn geometry from that. And we take, and you saw down there, we have the trapezoid, an unequal trapezoid on the floor. They build with those scaling. The scaling trapezoid, good for you, Paxton. And so then they're putting it into words rather than building it anymore. So the lower elementary builds them, we put them into the words. So the definitions are done. In this classroom, most everything is done with reference or resource materials. And in mathematics, we still have the foundation, but now they have to go into abstraction. So when you come back for language next month, you'll see that process all the way through.
Now, what kind of integration is it between, say, the emphasis on math and then on geography and then on language? Is there a way to integrate those units, or the teachers attempt to come to cross over?
Well, when we always try to set order. So anything in their environment, we try to set order, but we don't try to integrate it saying, if we're studying geography and we're studying Asia, we will be studying that in history as well. If we're studying North America, of course, we will be studying the Aztecs and the Mayans, and if we're studying South America, we will study the Incans. So we try to follow it through that way. With mathematics, we try to bring in like the Mayan math,
Right,
that type of thing. But it's not like really can be integrated that completely all the time. The abacus for China, that type of thing. We have 3 years for each classroom of children. So we try to, first year, give them a whole concept. Second year, fill in a different way along those timelines. And in the third year, we complete the process with all the inputs. So they never repeat what they've done before. So you'll see when we go into science and history and geography, the difference. But mathematics and language,
Pretty distinct.
pretty distinct, yeah. They have to get those basic concepts. Thank you.
So does each child get a lesson every day in math?
In this classroom, we do mathematics on Monday, Tuesday in language, Wednesday in geography, Thursday in science, and Friday in history. So they spend a whole day doing that. But in there, they go through about 30 lessons. I mean, they're getting lessons all week long.
Each child gets a lesson every day?
Oh yeah, at least a lesson. At least one lesson. I know I've given Noor like 5 lessons when I go over there for an hour.
So does
Yeah. I mean, I don't know how much she's absorbing, but we're giving lessons.
she absorbing? That's what we think.
Oh, I'm sure she's got to be absorbing something. She's not, the child that doesn't. She gets it. She just doesn't tell me. She's gonna get it.
But just by being in the classroom, what I observed is that the materials are always there. As you can see, they're always on the shelf, and the kids know that they can only get the materials that they have gotten lessons on. They see new materials and they respect, they don't go and get it. They know that they haven't gotten a lesson on that, and they go and talk to Rebecca, and Rebecca tells them, no, that's not yet for, that's not for
You're
you
not ready,
yet. You need
yeah.
to wait, you need to do first this, and that. So they say, okay, I want to do this. And that's how they get interested, because they see the displays and they can't touch them, so they really are eager to get to do the number 10 when they, but they have to start with number 1, so they do it. All the lessons they get taught, but they can't touch the ones that they haven't been taught yet.
And they can watch, they can observe a lesson to someone, and they know that they're not ready for that one yet. You can say, okay, I can't, you're not ready for this yet, but you can sit with me while I give this lesson to them. And they can sit there, and they see, oh no, I'm not ready for this one yet, but yet that puts in their mind that there's a gap, and they go back.
And she can add and subtract.
And she reads.
And she reads.
Yeah. Yeah, and she's doing the geography. I mean,
She's doing it?
yeah, she's push pinning.